Hello, welcome to the video. Today we're going to be solving question 1 in our transformations unit. So let's start and get into the mix, and we're going to start with part A. Write the equation of the transform function in explicit notation and identify the parameters. So let's first identify our goal here. Our goal is to match to the transformation function, like the form, okay? So that transformation 4 is y is equal to a f k bracket x minus d bracket plus c. That's basically the form that we're trying to aim for. Now, in this case, we'll write down the function that's over here. So this is our function that we're trying to transform. Now notice that the 3 could stay the same. It matches up here, and the 1 also matches. It's just this, like the one that's in the brackets don't match. So what we need to do is factor the inside in order to match it with the transformed form. So let's factor the inside. So we're factoring a 1 over 2 here, which is equal to x plus 2. And we have to substitute that back into the equation. So our new function would be y is equal to that's our new function essentially. Now what we need to do is identify a, k, d, and c. So we already figured out, let me draw this in a new color. We already found out that a is -3, which means that that's a vertical stretch by 3 and a reflection over the x-axis. Now k is 1 over 2, which means that it's a horizontal stretch by a factor of 2. For d, we have to solve for d essentially. So this part is d because it's matching over here. So x plus 2 is equal to 0. If we minus 2 on both sides, x is equal to -4. Therefore, d is equal to -2, sorry. So, therefore, d is equal to -2. Now, for c, it's pretty straightforward. It's just shifting up by 1. So, it's just 1. Now, for d, it's shifting to the left by 2 units. So, great. We solved the first part. Now, let's get to the second. Okay, so for the second part, what we need to do is figure out the mapping notation. So for our mapping notation, we have to write down the original table, obviously, which is f of x is the square root of x. So I'll write it down quickly. And we have to figure out a new table that is our transformed points. Now for the x values, the horizontal stretch by 2 means we have to multiply x by 2. So we can write 2 times x. And then the shift left by 2 units means that we have to subtract 4 from it because we're starting from 0, 0. Next, for our y values, we need to determine the transformations for that one. So it's a reflection over the x-axis, which means we have to multiply y by -1. There's a vertical stretch by 3, which means you have to multiply by 3. So we could just multiply y by -3. And then, since it's shifting up, we just have to add 1. Now I want you to pause the video and come back once you substitute all these points. Now I want to walk you through how you do that for 0, 0. So for this case, 2x minus 4, we have to substitute 0 into the equation in order to get the transformed point. So 2 times 0 is obviously 0, and then minus 4 is just -4. Now for this case, -3 times 0 is 0, and if you add 1, it's just 1. So pause the video and unpause it once you've figured out the transform points. I'm going to write down the answers after that. And so take your time with it, and there's no rush. Okay, so here are the transform points. The transform points are -2, -2, 0, -5, and 4, -8. These are our transform points, and they're going to be very useful for the next question. The next question is to graph this new transform point, or our new transformed function, essentially. So obviously I cannot like be as accurate, but it should be something sort of similar to like this, since it's reflecting it upside down and it's following the general curve essentially. Here's some tips for like graphing. Connect the points smoothly with the curve that represents the original square root shape, but flipped upside down due to the reflection. The graph starts at -4, 1 and curves downward to the right. And make sure you add an arrow to show that it continues in that direction infinitely. So most students make a mistake over here. Make sure you add that arrow, okay? And also make sure to like label the curve and the key point at -4, 1, which is the new starting point of that function. So let's move on with D, which is describing the transformations essentially. So I'm not going to write it down. I'm just going to explain it to you in words on the describing the transformations. So what we could say for 1 is it's a horizontal stretch by a factor of 2. There's a shift to the left by 2 units, a reflection over the x-axis, a vertical stretch by a factor of 3, and finally a shift up by 1 unit. So what I would write down is horizontal stretch by 2, shift left by 2 units, reflect over x-axis, vertical stretch by 3, and then shift up 1 unit. That's what I would write down. Now to move on to part E, we need to write the domain and range. The domain of the original function f of x is equal to the square root of x is all x values greater than or equal to 0, since we can't take the square root of a negative. So our original domain in this case is x is greater than or equal to 0. We'll label that as OG. That's for a transformed domain, we'll just write it as trans. It's after a horizontal stretch and a shift left by 2, the graph now starts at x is equal to -4. So the domain becomes x is greater than or equal to -4. So this is our new point. Now to explain that, what it's trying to say here is it previously used to cover only this area. But now, due to this transformations, it's covering this area now. This is just a rough demonstration, but it's shifting it to the left by 4 units, right? So therefore, x is greater than or equal to -4. Now, for a range, okay, our original range was y is greater than or equal to 0 because the graph starts at 0 and increases. So we could write that down here. Y is greater than or equal to 0. Now for our transform one, the function has been reflected and shifted upward, so it starts at a maximum of 1 and decreases. That gives us our new range, which is y is less than or equal to 1. So y is less than or equal to 1. So in this case, the original one was covering these quadrants 1 and 2 essentially. And now it's trying to cover quadrant 3 and 4, and it's shifting it up by 1. So it's going up by 1, and then it's just covering the other quadrants. That's reflecting it, since it's reflecting over the x-axis. So yep, these are our domains and these are our ranges. Now we have to explain that in words. Now I'm not going to write it down, I'm just going to say it because I feel like that's easier for you. So yeah, this is what I would write down for part F, essentially. The domain changed because the graph was stretched and shifted left. It now starts at x is equal to -4 instead of x is equal to 0. The range changed because the graph was reflected over the x-axis. It was stretched and then shifted up. It now has a maximum of y is equal to 1 and decreases from there. So what I'm exactly saying here is the domain changed due to the horizontal stretch and its shift left by 2 units. Originally, the graph started at y is equal to 0, but now it begins at y is equal to -4. The range changed because of the 3 vertical transformations. It was reflected downwards, stretched, and then shifted up. The graph now has a maximum value of y is equal to 1, and then it goes downward from there. So the new range is y is less than or equal to 1. And yep, that's it. We have fully answered question 1 by identifying the transformations, applying them, and with the mapping notation, and graphing the function, and clearly explaining the domain and range. and how are they reflected. Thank you for watching, and I hope this helped you understand transformations better.